Day 5. Today we are going to go over greatest common factor, equivalent fractions, mixed numbers and improper fractions, and turning fractions into decimals and vice versa. So first thing we're going to do is greatest common factor and divisibility. One number is divisible by another if the remainder is 0 when you divide the two. The rules below can be used as a quick check for divisibility. A number is divisible by 2 if the ones digit is either 0, 2, 4, 6, or 8. 3 if the sum of the digits is divisible by 3. 4 if the number formed by the last two digits is divisible by 4. 5 if the ones digit is either 0 or 5. 6 if the number is divisible by 2 and 3. 8 if the number formed by the last three digits is divisible by 8. 9 if the sum of the digits is divisible by 9, and 10 if the ones digit is a 0. Recall that whole numbers or a whole number is divisible by each of its factors. The factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 20 are 1, 2, 4, 5, 10, and 20. The common factors of 12 and 20 are 1, 2, and 4. The greatest common factor of 12 and 20 is 4. So if we look at some examples, in a division problem where the remainder is 0, the divisor and the quotient are a factor pair of the dividend. So if we look at a division problem, if we have 39 divided by 3, the 39 is the dividend, the 3 is the divisor, the 13 is the quotient. So 3 times 13 is 39, so 3 and 13 are factor pairs of 39. For example 1, it asks what the factors of 42 are. The last digit of 42 is 2, so it's a factor of 2 is an even number, so it's a factor or 2 is a factor of it. 4 plus 2 is 6, and 6 is divisible by 3, so 3 is a factor of it. Since 2 and 3 both go into 42, 6 is also a factor. To find the other factors by pairing, 2 times what is 42? Well, that's 42 divided by 2, which is 21. 3 times 14 is 42, and 6 times 7 is 42. To find the greatest common factor of 36 and 48, you'd have to find the factors of 36, which are 1, 2, 3, 4, 6, 9, 12, 18, and 36. And the factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Their common factors are 1, 2, 3, 4, 6, and 12. Their greatest common factor is 12. If we look at the short response questions, we are finding the greatest common factor for 11, which is 24 and 64. So for this one, what I'm going to do, I'm going to draw it down here. We have 24, we have 64. Well, 24 is 1 and 24. It's even, so 2 and 12. 3 goes into it 8 times, 4 goes into it 6 times. For 64, we have 1 and 64. 2 and 32. 3 does not go into it evenly. 4 goes into it 16 times. 5 does not go into it evenly. 6 does not go into it evenly. 7 does not go into 64 evenly, but 8 goes into it 8 times. So if we look at the ones that are the common factors, we have 1, we have 2, we have 4, we have 8, and that is it. Our greatest common factor is the 8. For 12, they give us 18 and 42. 18 is 1 and 18, 2 and 9, 3 and 6. The 42 is 1 and 42, 2 and 21, 3 and 14. 4 does not go into it evenly. 5 does not go into it evenly. 6 goes into it 7 times. So our common factors are 1, 2, 3, and 6. Our greatest common factor is 6. For 13, we're given 78 and 195. So for the 78, we have 1 and 78, 2 and 39. 3 goes into it 26 times. 4 does not go into it evenly. 5 does not go into it evenly. 6 goes into it 13 times. Other than that, I think that is it. Yeah, because 9 does not go into it evenly. So that's all of the numbers for 78. For 195, we have 1 and 195. 195, if you add up all of those numbers, the 1 plus 9 is 10, plus 5 is 15. 3 goes into it evenly then, and then it's 65 times. 195 and 5 is 5 and 39. 6 does not go into it evenly because it's not divisible by 2. If we add the 1 and the 9, that's 9. That's 10 plus 5 is 15. 9 does not go into 15 evenly, so 9 does not go into it. 195, if we divide it by 7, that doesn't go into it evenly. So I think that's all that we have. Let's try 13 as well. So 195 divided by 13 gives us 15. So 13 goes into it 15 times as well. Okay, so common factors are 1, 2, no, 3, yes, 6, no, 13, yes, 26, no, 39, yes, 78, no. So our greatest common factor is 39. So if you see how I did that, I went through all of the factors of my smaller of the two numbers, which is the 78, and then the ones that are the greatest out of those common factors is my greatest common factor. So for 14, we're given 54 and 189. So 54 is 1 and 54, 2 and 27. 3 goes into it 18 times. 2 and 3 go into it evenly, so 6 goes into it evenly. 4 does not. 6 goes in 9 times, and then that would be it. For the 189, we have 1 and 189. 2 does not go into it evenly. However, 3 goes into it 63 times. 4 does not go into it evenly because it's not 8 plus 9 is 17. 4 is not divisible by, or 17 is not divisible by 4. 5 does not go into it evenly. 6 does not go into it evenly because 2 does not go into it evenly. Let's try 7. 189 divided by 7 is 27. So if we also added those up, 9 is divisible by it. 9 goes in 21 times. If you see here already that 27 is our highest number, that's the common, so that's our greatest common factor. With a lot of these, you don't have to really work them out completely. It is good to do so to make sure that your answer is correct, but some of them, it's not necessarily to completely find every single factor of the number unless it asks you to state the common factors as well. For 15, they give us 68, 153, and 204. So with the 68, that's 1 and 68, 2 and 34. 3 does not go into it evenly. 4 does not, or yes it does. 4 goes into it 17 times. 5 does not go into 68 evenly. 6 does not go into 68 evenly. 7 does not. 8 does not. 9 does not. 12 doesn't. 13 does not. And you're just going to get up to 17, and then that's going to be your repeating. So what you could do with all of these is you can ask yourself, does 68 go into 153 and 204 evenly? If we divided both of those by 68, for the 153, it doesn't go in evenly, so that's not your greatest common factor. For 34, if you did that, so 153 divided by 34, that gives you 4.5. That's not a factor of all three. What about 17? 153 divided by 17, that's 9, and then 204 divided by 17 is 12. So 17 is our greatest common factor. So you could do it that way, or you could find your factors. So the 153 is 1 and 153. 2 doesn't go into it evenly. 3 goes into it 51 times. 153 and 4 are not divisible if we divide it by, let's say, 7. We don't get a number there either. 8, no. 9, 17. For 204, we have 1 and 204, 2 and 102. 3, I don't think, does it? No, 304. 204 divided by 3 is 68, yes. So 3 and 68, 4 and 51. 204 divided by 6 is 34. 204 and 8, no, 204 and 9. Oops, let's see. Hold on. 204 divided by 8, no. 204 divided by 9, no. 10, no. 12, maybe. 17. All right, so your greatest common factor there is the 17. So they're all divisible by 1. They're not all divisible by 2. They're not all divisible by 3. They're not all divisible by 4. But they are all divisible by that 17 as well. The next part that we are working through is equivalent fractions. Fractions that represent the same quantity are called equivalent fractions. So 2/3, 3/6, and 4/8 are all equivalent fractions since they simplify to be 1/2. A fraction in lowest terms or simplest form when the greatest common factor of its numerator and denominator is 1. To write a fraction in simplest form, divide the numerator and the denominator by their greatest common factor. To create equivalent equivalent fractions, the only thing you'd have to do is multiply both the top and the bottom of that fraction, the numerator and the denominator, by the same number. So if we look at some examples that are done for us, for 1, it asks us to find the fraction of the denominator of 24 that is the equivalent to 2/3. So we just have to multiply the top and the bottom of this fraction by 24. By something to get 24 in the denominator. So 3 times what is 24? It's 8. So we multiply the 2 by 8, and that gives us 16/24. For 2, it asks, are 3/20 and 12/80 equivalent? Well, 20 times 4 is 80, and 3 times 4 is 12, so yes, those are equivalent. You could also cross-multiply to find if they are equivalent. So you would do 3 times 80, which is 240, and 20 times 12, which is 240. For 3, it asks, are 21/56 and 3/7 equivalent? Well, 56 divided by 6 is 7. 56 divided by nothing. No, by 8. Yes, 56 divided by 8 is 7. However, you cannot divide 21 by 8, so that is not, those two are not. You could also cross multiply with these. The 21 times 7 is 147, and the 56 times 3 is 168. So because they are not the same, when you cross multiply, then they are not equivalent. For 4, it asks you to write 18/24 in simplest form. You could start by dividing these by 2. If you did, you would have 9/12. However, they're both divisible by 3, so that's 3/4. For 11, we're replacing each set of parentheses with an equal or not equal. So for these, we can cross multiply, so we would have 3 times 12, which is 36, and 2 times 15, which is 30. Those are not equivalent, so we put a not equal sign in them. For B, we have 24/27 and 8/9. Well, we know 27 divided by 3 is 9, and 24 divided by 3 is 8, so those two are equal. You could, again, cross multiply. For C, we have 7/12 and 49/84. So if we took the 7 and multiplied it by 7, we get 49. 12 times 7 is 84. So those two are equal as well. For D, we have 15 over 40 and 25 over 64. The 15 times 64 gives us 960, and the 40 times 25 gives us 1250. So because these are not equal to one another, the fractions are not equal to one another. For 12, we're asked to write each fraction as an equivalent fraction that has the denominator shown in parentheses. So for A, we are given 12 over 3 and we want something over 42. Well, 42 divided by 3 gives us 14. So if we multiply that by 2, we get 28 over 42. For B, we have 5 over 16. We want to turn it into something over 80. So 80 divided by 16 gives us 5. So we're going to do 5 times 5, which is 25 over 80. For C, we have 85 over 100. So we want to turn it into something over 20. We take the 100, divide it by 20, we get 5. So 85 divided by 5 gives us 17 over 20. For D, we have 198 over 432. We want something over 24. So we're going to take the 432 and divide it by 24. We get 18. We then take the 198 and divide that by 18 and get 11. So that's 11 over 24. For 13, it asks us to write each fraction in simplest form. So for A, we have 18 over 30. So these are both divisible by 3. They're also both divisible by 6. So I'm going to divide both of them by 6 to get 3 over 5. For B, we have 96 over 32. These are both divisible by 8. So we are going to have 12 over 4, which is also 3. For C, we have 48 over 72. When we divide these, we are going to divide both of them by 8. The 48 divided by 8 is 6. Let's change the color here. This is 6. The 72 divided by 8 is 9. So this is also 2/3. And then for D, we have 35 over 53. The 35 is divisible by 7. The 53 is not. So this, let's see, a 53 is a prime number, I believe. Yes, it is. So it is prime. So that is our number. For 14, it tells us to write 3 fractions and name the point on the number line. So for A, we are looking at Q. So you got to look at all of these. So you want to look at to see how many dashes there are and count up all of those dashes. So we have 1, 2, 3, 4, 5, 6. So out of all of these, this is 1 out of 6, 2 out of 6, which is 1/3, 3 out of 6, which is 1/2, 4 out of 6, which is 2/3, and 5 out of 6. So now that we've done this, this is going to be a little bit easier for us to identify what fraction of a whole all of these numbers are at. So for Q, we're at 1/6. For B, we have R, which is 1/3. S is at 2/3. And T is 5/6. 15. It says, a case of juice contains 24 bottles. What part of the case is 18 bottles? Write your answer in those terms. Okay, so we just put the 18 over the 24, and then we simplify. 18 and 24 both divisible by 3. 3 goes into 18 6 times. 3 goes into 24 8 times. This is also both divisible by 2, so this is 3 over 4. 16 says Larry walked 5/8 of a mile. Noreen walked 7 over 24 of a mile. Did they walk the same distance? Well, no, because 8 times 3 is 24, but 5 times 3 is not 17. If not, who walked further? and Noreen walked farther. So no, Noreen walked farther. Because the 17 is greater than the 15. For 17 says a survey reported that 3/4 of people surveyed owned a computer. If 390 people in the survey owned a computer, how many people were in the survey group? So it's telling you 3/4 is equal to 390 out of the total. So we're finding x. So we can say to ourselves, 3 times what is 390? Well, 390 divided by 3 gives us 130. So we're going to multiply that 4 by 130. And that gives us 520 people. For the next part, we are dealing with mixed numbers and improper fraction. A mixed number is a fraction that has a whole number in front of it. An improper fraction has a number that is higher in the numerator than in the denominator. So with these, we are looking at writing 3 as an improper fraction with the denominator of 8. Well, that gives us 3 over 1, and we have to turn the 3 over 1 into something over 8. Well, 3 times 8 is 24, so that's 24 over 8. For 2, it asks to write 17 over 6 as a mixed number. So 6 goes into 17 2 times with 5 left over, so it's 2 and 5/6. For 3, it asks to write 4 and 2/3 as an improper fraction. When we do this, we take the 4, which is the whole number, multiply it by the denominator, the denominator, and then add the numerator. So 4 times 3 is 12, plus 2 is 14. We keep that over the denominator of the 3, and we have 14 over 3. So for 11, with these short response questions, we are writing each fraction as an improper fraction. So for A, we have 7 and 2/3. So 7 times 3 is 21, plus 2 is 23 over 3. For B, we are given 8 and 3/5. So 8 times 5 is 40, plus 3 is 43. Keep it over the 5. For C, we have 10 and 7/8. So 10 times 8 is 80, plus 7 is 87 over 8. And then D, we have 6 is equal to something over 8. Well, 6 times 8 is 48. So that's just 48 over 8. For 12, we're writing each as a mixed number or whole number. So for A, we have 27 over 4. 4 goes into 27 evenly 6 times. We would have 3 left over, so that's 6 and 3/4. B, we have 39 over 8. So if we do 39 divided by 8, we have 4. 4 times 8 is 32, so 39 divided by 32 is 7 over 8. For C, we have 49 over 7, which is just 7. D, we have 85 over 12. So if we divide the 85 by 12, we get 7. 7 times 12 gives us 84. So that would give us 1 left over. So that's just 7 and 1/12. For 13 through 16, we're finding the value of n. So for 13, we have 5 and 4 over 4. So this is the same thing as 5 plus 1, which is 6. For 14, we have 8 and 11/6. Well, 11 over 6 is the same thing as 1 and 5/6. So that's 9 and 5/6. For 15, we have 10 and 11 over 3 is the same thing as 13 with something over 3. So 3 goes into 11 3 times with 2 left over. So that's going to be 13 and 2/3. Oops. And then for 16, we have 12, and n over 8 is equal to 13 and 3/8. Well, if we take 1 away from 13 and add that to the 3 over 8, it would be 8 over 8 plus 3 over 8. So 8 plus 3 is 11 over 8. So n is 11. with fractions and decimals, we are working with terminating and repeating decimals. So we actually saw this when we were dividing those numbers, and we were giving our answer in decimal form. So it's the same exact thing. We just have to remember that the numerator for our fraction goes underneath our division house, and the denominator is on the outside. So if we look at some examples, for 11, we are converting each fraction into a decimal. So for A, we have 17 over 50. So we're going to do 17 divided by 50, 11A. 17 over 50. So the 50 is going to go on the outside. The 17 goes on the inside. 50 does not go into 17, so we're going to automatically just put the decimal with the additional 0. So 50 goes into 170 3 times with 3 times 5 is 15 with the 0. So subtract these, we are left with 20. I'm going to add a 0, bring it down. 50 goes into 200 4 times, so that's 0.34. For B, they give us 4 over 9. There's a rule with these 9s. If you have a 9 in the denominator, it tells you that the number on top repeats. So this 4 over 9, you could do 4 divided by 9, or you can just say to yourself, okay, it's over 9, so that 4 is just going to repeat itself. So it's going to be 0.4 repeating. For C, we are given 5/6. So 11C, we have 5 over 6. So it's 5 divided by 6. The 6 goes on the outside. The 5 goes on the inside. We're going to turn it into a 50. So 6 goes into 50 8 times with 48. So we subtract those, we get a 2. Add a 0, bring it down. 6 goes into 20 3 times with 18. And we get 2 left over. If we add a 0, bring it down, we're at the same place we just were. So 3 is going to repeat. So this one is 0.83 repeating. And the bar notation is what is that bar that's over that 3. It's only over the 3. For D, we have 7 over 20, which is 7 divided by 20. So 11D, 7 over 20 is going to give us the 20 on the outside, the 7 on the inside. We're going to turn that into 70. Put our decimal point up there. So from here, we are going to divide these two. The 7 goes in, or sorry, the 20 goes into 70 3 times with 60. So we're going to subtract that. We get 10. We add a 0. We bring it down. 20 goes into 100 5 times. So that's 0.35. For 12, we convert each decimal into a fraction or mixed number in simplest form. So for A and B, we have a whole number. For A, our whole number is 6. Our B, we have a whole number of 3. So those are going to be our whole numbers, of our mixed numbers, regardless. For A, we are given 6.08. So that 8 is in the hundredths place. So that's going to be 8 over 100, which simplifies to be 4 over 50, which is 2 over 25. So it's 6 and 2/25. For the example B, we have 3.125. That 125, that 5 is in the thousandths place. So that's going to give us the 125, over 1,000. If we simplify these, the 125 over 1,000 is point, yes, but if we divide, let's say we divide both of them by 25, we get 5 over 40, which is 1 over 8. So that's 1/8, 3 and 1/8. For C, we have 0.135 repeating. So this 135 is actually going over 999. So the number of the terms underneath the bar notation tells you the amount of nines in your denominator. So it's just 135 over 999. And then for D, we have 0.5625. That 5 is in the 10,000ths place. So we have 5625 over 10,000. If we divide both these by 5, we get 1125 over 2,000. If we divide it by 5 again, let's try 25. Yes. If we divide it by 25, this is going to give us 45 over 2,000 divided by 25 is 80. The 45 and 80 are both divisible by 5, so this is 9 over 80 divided by 5 is 16. You cannot simplify that any further, so it's just 9 over 16. For 13, we are comparing these. So for A, let's move this over here. We have 0.82 and 4/5. The 4/5 is the same thing as 0.8, so the 82 is greater. For B, we have 1.55 and 1 and 11 over 20. Well, that 11 over 20 is the same thing as 0.55, so these two are equal to one another. For C, we have 2/3 and 0.66. That 2/3 is 0.6 repeating. So that 6 is never going to stop repeating. So that 2/3 is actually greater than the 0.66. For D, we have 1.575 and 1 5/8. The 5/8 is 0.625. So the 1.625 is greater than 1.575. So the 1 5/8 would have our sign open to it. For 14, we are adding these. So we have 3/4 plus 0.65 plus 1/5. So my 0.65 is the same thing as 65 over 100, because the 5 is in the hundredths. If I simplify this, the 65 turns into 13 over 20. So we can find the greatest common factor here, which is 20. So this 3/4 is something over 20. We multiply the 5 by 4 to get 20, so 3 times 5 is 15 over 20. And then the 1/5 is the same thing as 4 over 20. So if we add all of these up, the 15 plus the 13 plus the 4 gives us 32 over 20. The 20 and the 32 are both divisible by 4, so that's going to be 8 over 5, which is 1 3/5. The 15, we have 4/5 times 0.9. You could turn the 4/5 into a decimal and then multiply the two decimals, or you can turn the 0.9 into a fraction. I like working with fractions more than I like working with decimals, so I'm actually going to turn the 0.9 into a fraction and put it over 10. So I'm going to do 4/5 times 9 over 10. The 4 and the 10 can cross simplify to become 2 and 5. So I'm doing 2/5 times 9/5, which gives me 18 over 25. For 16, we have 3.5 minus 1 7/8 plus 0.155. All right, so what I'm going to do, this 3.5 and this 1 7/8, if I turn the 1 7/8 into a decimal, I have 3.5 minus 1.875. So we can add the zeros in there. This 0 is going to turn into a 10, making this a 9, and this 5 a 4. The 4 becomes a 14, making the 3 a 2. So 10 minus 5 is 5, 9 minus 7 is 2, 14 minus 8 is 6. Put down my decimal point, 2 minus 1 is 1. If I then add 0.155 to this, I'm going to get 10, carry the 1. 5 and 2 is 7, plus 1 is 8. 6 and 1 is 7. Put my decimal point down, add the 1 in. So I get 1.78. You're writing each answer as a decimal, so if we change these answers to be decimals, this 3/5, oops. All right, this 3/5 is going to be 0.6, so that's 1.6. This would be your answer for 14, and then the 18 over 25 is going to be 0.72, so 0.72 is your answer for number 15. For our practice, our first question asks us which set of digits could not be used to form 3-digit number that is divisible by 4. We're going to skip this one, and I'm going to tell you to skip it because it's way out of what we're doing. So for 2, which number is divisible by 9? So if we divide each of these by 9, we should get a whole number if it is divisible by 9. So for F, we have 3,796. If we divide that by 9, we get 421.7 repeating. So that one does not work. For G, we have 10,027. If we divide that by 9, we get a number that repeats as well, so that does not work. For H, we have 213,459 divided by 9 gives us a number that repeats as well, so that doesn't work. So J is going to have to work. So 1,407,33 divided by 9 gives us 156,337. So that one works. J was your answer for 2. For 3, it asks which number is divisible by 8. So we're doing the same thing. So for A, we have 4,124 divided by 8 gives us 515.5. That one does not work. For B, we have 7,816 divided by 8. We get 977. So that one works. For 4, it asks which number is divisible by 3 but not 6. We know that if a number is divisible by 6, it's also divisible by 3 and 2. So we just have to see if the number is divisible by 6. If it is divisible by 6, then it's not our answer. 18 is divisible by 6, so F is not our answer. 48 is divisible by 6, so G is not our answer. 72 is divisible by 6, so that's not our answer. J is our answer. For 5, it asks what the greatest common factor of 48 and 54 is. So 48 is 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. 54 is 1 and 54, 2 and 27, 3 and 18. 4 does not go into it evenly, 5 does not go into it evenly, 6 goes in 9 times. So the greatest, all of our factors that are the same are 1, 2, 3, 6, and that is it. So our greatest common factor is 6. For 6, it asks which is the greatest common factor of 18 and 108. So looking at this, look at J. 18, does it go into 18? Yes. Does it go into 108 evenly, though? Yes, it does. It goes in 6 times, so J would be your answer. So you, with these, if it gives you answer choices like this where it's multiple choice, start with your highest number. Looking for greatest common factor, so it's going to be your highest number out of the 3 there. Try it. If it works, then that's your answer. If it doesn't work, then try the next highest number. For 7, it asks what the greatest common factor of 28, 42, and 98 is. So I'm going to start with the 28. 28 is 1 and 28, 2 and 14. 3, it does not go into it evenly. 4 goes into it 7 times. And that is it. So try 42. 1 and 42, 2 and 21, 3 and 14. 4 does not go into it evenly. 5 does not go into it evenly. 6 goes in 7 times. Right now, our highest number, that's the same as the 14. So we got to check 98. For 98, we have 1 and 98, 2 and 49. 3 does not go into it evenly. 4 does not go into it evenly. 5, no. 6, no, because 3 does not go into it evenly. What about 7? 98 divided by 7 gives us 14. That works. Do we need to go any further? No, because we know that the 14 is the same in all 3. So our greatest common factor is 14. For 8, it asks how many factor pairs does 90 have? So for 90, we have 1 and 90, 2 and 45, 3 and 30, 4, no, 5, yes, 5 goes into 9 once with 4 left over, so that's 18. 6 goes into it, goes in 9 once with 3 left over, so that's 15. 7, no, 8, no, 9 and 10. 11, no. 12, no. 13, no. 14, no. 15, yes. So how many factor pairs is this? 1, 2, 3, 4, 5, 6 factor pairs. For 9, it asks which number has 4 as a factor but not 8. So for A, we know 8 goes into 54, so that's not an option. For B, 68. 68 and 8 are not divisible. Does 4 go into 68 evenly, though? 68 divided by 4 is 17, so B is our answer. 10 says if 2 numbers are both primes, their greatest common factor is 1. If they're both prime, it's that number and 1. So the only common factor they're going to have is 1. So the greatest common factor is going to be 1. For our next section of practice, we have that which fraction is not equivalent to 4/5. Well, 4/5 is the same thing as 8 over 10. If we multiply it by the 4 by 9, we get 36. 5 times 9 is 45, so B is not the answer. 4 times nothing is 21, so C is not equivalent. For 2, it asks which fraction is equivalent to 3/8. So 3 times 3 is 9, but 3 times 8 is not 40, so F is not right. For G, 3 times 7 is 21, 8 times 7 is 56. G is your answer. For 3, it says replace the question mark to make a true statement. So 81 times 9 is 9. So 81 divided by 9 is 9. 36 divided by 9 is 4. 4 asks which pair of fractions is not equivalent. So for F, we have 2 over 6 and 10 over 30. So 2 times 5 is 2 times 5 is 10, 6 times 5 is 30. This one works. For G, we have 15 over 50 and 6 over 20. So 15 divided by nothing is 6. So this one here is not going to work. You could also see that 50 divided by nothing is 20. However, let's see if we can simplify these to be the same. So before we make the conclusion, the 15 over 50, they're both divisible by 3. That's going to be 5, or sorry, 3. Yeah, it is going to be 5. No, they're both divisible. Yes, they're both divisible by 5, so it's going to be 3 over 10. For 60 over 20, they're both divisible by 2, so that's 3 over 10. So these two are still equivalent, so this one works as well. For H, we have 3/5 and 27 over 45. 3 times 9 is 27, 5 times 9 is 45. So these two are equivalent as well. So J has to be our answer. For J, we have 16 over 40 and 7 over 15. The 16 over 40 can simplify to be 4 over 10, which is 2 over 5. 2 over 5 can in no way be 7 over 15 because 5 times 3 is 15 and then 2 times 3 is 6, not 7. For 5, it asks which fraction is in simplest form. For A, we have 3 over 21. That's not right because that's 1 over 7. For B, we have 5 over 30. No, because that's 1/6. For C, we have 9 over 25. Yes. For 6, it says to simplify 27 over 64. 27 and 64 are both divisible by 1. They're not divisible by anything else, so it is 27 over 64. You gotta think your factors of 27 are 3 and 9. 9 is 3 and 3. 3 is the only factor, and 9. So neither 3 nor 9 go into 64 evenly. So it is prime. Or it's not prime, it is simplified. For 7, it says the simplest form of 68 over 200 is. The 68 and the 200 are both divisible by 2. If we divide the 68 by 2, they're also both divisible by 4. If we divide both by 4, we get 17 over 50. So B would be our answer. 8 says that Todd made a quilt with 300 squares. There were 90 blue squares. What part of the quilt was blue? So that's 90 over 300. We can get rid of that 0 in both, so it's 9 over 30. They're both divisible by 3, so that's 3 over 10. For 9, it asks which fraction represents the same amount as shown shaded. The shaded ones are this, here, here, these ones that I'm shading in here. Okay, so in total, we have how many that are shaded? 1, 2, 3, 4, 5, 6, 7, 8. How many total do we have? 9, 10, 11, 12. If we were to simplify this, that gives us 2 over 3. So that's 2/3. Which fraction represents the same amount, though? So the same amount here, we can look at this. So let's see. If we multiplied the 8 by 5 to get 40, I'm looking at D. 8 times 5 is 40, but 12 times 5 is not 50, so D does not work. The 15 over 21 is not an option either because 2 times nothing is 15. 2 times 15 is 30, and 3 times 15 is 45, so C would be our answer. 10 asks which fraction does not belong. So if we simplify all of these, we can tell which one does not belong. So F, we have 15 and 36. They're both divisible by 3. We get 5 and 12. For G, we have 35 over 60. Those are both divisible by 5. That gives us 7 over 12. H, we have 30 over 72. Those are both divisible by 6. That's 5 over 12. And then J, we have 45 over 108. 108 is divisible by 9, and that is 5 over 12. So G does not belong. For our next part, 1 asks which is an improper fraction. An improper fraction means that you have a number on top greater than the number on the bottom, so B would be your answer. For 2, it tells us to write the shaded amount as a mixed number. So we have 1, 2, and 1, 2, 3, 4, 5 out of 6, 7, 8. So 2 and 5/8. 3 asks which fraction is less than 1. For A, we have 15 over 14. No, because 15 is greater than 14. B, we have 31 over 30. No, because 31 is greater than 30. For C, we have 77 over 76. That's also a no, because 77 is greater than 76. And then D, we have 112 over 113. 112 is less than 113, so that is less than 1. For 4, it tells us that 81 over 7 is equivalent to what? 81 over 7. So 81 divided by 7. If we take that 7 and ask ourselves, how many times does it go into 81 evenly? That's 11 times with 77. If we divide the 81 by 70, if we subtract the 81 from, and the 77, we're left with 4. So that's 11 and 4/7. 5 asks which represents a whole number. The 3 underneath the 23 is not a whole number. 6 does not go into 58 evenly. 4 does not go into 34 evenly, but 9 goes into 72 evenly 8 times. So D would be your answer for number 5. For 6, we have 9 and 4/5 is equivalent to, the 9 and 4/5 is the same exact thing as saying 9 times 5, which is 45, plus 4 is 49 over 5. 7 asks that 91 over 8 is equivalent to what? Well, 8 goes into 91 11 times with 88. So 91 minus 88 is 3. So that would be 3 over 8 that's left over. 8 says granola bars come in packages of 8. If Keith has 5 full packages and one that is 5/8 full, how many granola bars does he have? Well, if there's 8 in total and there's 5 packages, that's 8 times 5, which is 40. And then there's 5/8 left, so that's 5 plus the 40, which is 45 bars. For 9, we have 63 divided by 4. We're writing it as a mixed number. So 63 goes in, 4 goes into 63 how many times? 4 goes into 6 once with 4. We subtract, we have 2. We bring down the 3. 4 goes into 23 5 times with 20. We subtract, we have 3. So that's 15 and 3/4. 10 tells us to replace the brackets with the appropriate mixed number. We have 2,250,000 is equal to what million? So that would be 2.250. Here, let's do this. 2 and 25. So here. Okay, so that 250 would be over, no, that 250 would be over 100,000. Let's try this a different way. All right. If we do, why can't I erase that? There we go. All right. So we have 2.25 million. 25 million is 1/4, so that's 2.2 and 1/4. So that's this here. For 1 in your last section, it tells us the decimal form of 9 over 25 is. We'll turn this into a fraction that's something over 100. It would be a lot easier for you. If you multiply this by 4 and this 9 by 4, we get 36 over 100, which is 0.36. 2 says which pair of numbers is equivalent. So for F, we have 3/4 and 0.65. 3/4 is 0.75, so that's no. 4/5, however, is 0.8, so G would be our answer. 3 asks the decimal form of 11 over 4 is what? We would take the 4, put on the outside, the 11 would go on the inside, 4 goes into 11 through 2 times with 8. So 11 minus 8 gives us 3. Add the 0, bring it down, put your decimal point up. 4 goes into 30 7 times with 28. Subtract, we get 22. Add the 0, bring it down. 4 goes into 25 times. So that's 2.75. 4 asks for the decimal form of 1 and 1/6. So this 1/6 is the same thing as 1.16 repeating. For 5, it says 0.074 with the 0.74 repeating represents 0.074074074 repeating. So that's C. For 6, it says which fraction is equivalent to 0.28. The 8 is in the hundredths. So 28 over 100 is equal to, divide both, if you want to divide both by 4, you could. 4 goes into 28 7 times. 4 goes into 125 times. So that's 7 over 25. 7 asks which mixed number is equivalent to 2.65. So that 5 is in the hundredths. So that's going to be 2 and 65 over 100. We can divide both of these by 5, and we get 2 and 13 over 20. So that's C. 8 says Daniel ran 4.3 repeating kilometers. This distance is the same as 4.3 and 1/3. That's what it is. J is 4 and 1/3. 9 asks which number is not equivalent to the others. For A, we have 1.18. C is 1.8. Those are two totally different things. For B, we have 9 over 5, which is 1.8. And then D, we have 1 and 20 over 25. The 20 over 25 is 0.8, so that's 1.8 as well. So A is not equivalent to the others. For 10, we have 0.7 minus 3 over 10. The 7 is in the tenths place, so that's the same thing as 7 over 10 minus 3 over 10, which gives us 4/10, which is also 0.4. You can write it like this, or you can give 2/5. They're the same thing.